Hello students. So in the previous class we were talking about that of the commercial unit of energy. Okay, so we studied about the commercial unit of energy. Commercial unit of energy is also known as the energy that we used for a larger unit or on a commercial purpose or on a larger scale. Okay, and the commercial unit of energy we came to know, and that is, students, it is kilowatt hour. Okay, so to measure the electrical energy on a larger scale, then we use the term for it, and that is the kilowatt hour is that unit to measure it. Okay, so in this one only we study that the joule, since it is the smaller quantity, so we cannot use it for the of the larger scale, and because of that we must use a large unit, and that large unit will give us a value. So that is why this there is a need of this commercial unit of energy. When we talk about the kilowatt hour, student, or commercial unit of energy, it means that the amount of energy consumed, amount of electrical energy consumed when an electric appliances of a 1 kilowatt is used for 1 hour. Okay, that is what, that is the commercial unit of energy. Okay, so basically when we consume an electric energy, electrical energy, and when we use an appliance that is of a 1 kilowatt for 1 hour, it will give us a value of a 1 kilowatt hour. In the same only, in the kilowatt hour, we see the relationship between the commercial unit of energy and SI unit of energy, student. Commercial unit of energy, we study that the kilowatt hour is equals to 3.6 into 10 the power 6 joule. Okay, so this is the relationship between that of the kilowatt hour and that of the joule. So whenever the question is asked that this kilowatt hour is equals to how much joule, what you have to do, you have to simply multiply it by 3.6 into 10 the power 6 and you will get the answer. On the same basis, we study one thing, student, that 1 kilowatt hour will be equals to 1 unit of electrical energy. And this unit, the value of the unit also varies from the place to place. In some places it is the 5 to 6 rupees for 1 unit of electrical, 1 unit of that of the electrical energy. Okay, so 1 unit, it means that is equal to 1 kilowatt hour. So if the question is asked that this much unit you have to convert it into joule, or this much kilowatt hour you have to convert it into joule, in both the cases you will use the same relationship and you will multiply that particular unit with that of the joule, that is 3.6 into 10 the power 6 joule, and you will get the value. Okay, so either we have to find the value of the kilowatt hour to joule, or 1 unit to that of the joule, we will use the same relationship. Not only this, student, if 1 kilowatt hour is given, or if value is given in a kilowatt hour, or instead of that of the kilowatt hour, if it is written as a unit, then also you have to take it as an electrical energy only. You can say that 1 kilowatt hour is equals to 3.6 into 10 the power 6 joules. Instead of that, if the question is that in a 1 kilowatt hour or in a 1 unit, and so we will take both of them as electrical energy, and you know the formula, that is power is equals to energy consumed upon time taken. So we will use the same formula, and for the kilowatt hour we will use the value of that of the electrical energy. Putting the value, we will get that of the power. Okay, so we can say, student, either it is a kilowatt hour or the 1 unit, both are the same thing. Okay, on that basis we saw some of the numericals also, students, related to that of the commercial unit of energy. Now today we will talk about another type of energy, and that is the transformation of energy, students. Transformation of energy, student. When we talk about the transformation, it means we are saying that energy can be get converted into the other energy. It can be transferred into the other energy. So that is what transformation of the energy, conversion of the energy from one form to that of the other energy. Okay, so transformation we can understand it by conversion. So we can say the conversion of energy from one form to other form. That is what? That is the transformation of energy, student. So this is the transformation of energy, and that is conversion of energy from one form to another form, student. So it means that energy which is present in an object can be transformed, can be converted into the other form of energy. There are a lot of examples with this. We can understand this concept of the transformation of energy, student. Like, if suppose a ball is there which is lying on the roof of the building, okay, so if it is kept, if it is lying on the roof of that building, then what will happen? You will see that since it is present at a certain height and it is at a rest position, or it went go through the one place, there is a change in the position from the lower to that of the higher end, so it is having a lot of potential energy. Okay, so if a ball is there and that ball is at certain height, okay, so at that time the potential, the energy which is having, which is possessed by this ball is the potential energy. So we will say that this ball is having the maximum potential energy. Okay, now what happened? You throw the ball from that of the building, from that of the roof. Okay, so it starts coming down to that of the ground. As it starts coming to the ground, student, before that it was at a rest position, but since it was at a heighted one, we will say the potential energy is maximum there, because we had done some work in carrying the ball from the ground to the roof. Okay, so that work done is stored in the form of energy, and that we call as a potential energy. Okay, so here the ball which when it was at a roof, at that time the potential energy was maximum. When you throw it through that of the building, it starts coming down. Okay, and you will say that as it starts coming down, it starts moving, or it comes in a motion. Right? The ball comes to motion or starts moving to the ground. At that time, you know that the energy possessed by a moving body is the kinetic energy. So, from this ball as it is coming to the ground, it starts losing that of the potential energy and starts gaining the kinetic energy. So on that basis, you can say that as it starts coming down, the potential energy decreases and the kinetic energy increases. Okay, so potential energy decreases, but the kinetic energy increases and it starts moving down to that of the ground. As it reaches to the ground, before coming to the rest, it will have a maximum kinetic energy and minimum potential energy, or we can say potential energy will become zero, students. Okay, so at that time when it was kept at the roof, at that time potential energy was maximum and kinetic energy was zero, because the object was at rest position. Okay, as it starts moving down, this potential energy starts decreasing and kinetic energy increases. When you see the value, student, of that of the potential and the kinetic energy, you will see that the amount of energy used by that of the potential energy will be equals to the amount of energy gained by that of the kinetic energy. It means there is no loss of the kinetic energy. Okay, there is no loss of the energy. Okay, so here we are simply talking that the one energy get converted into the other energy. Potential energy get converted into the kinetic energy, students. Okay, so here what happened? There is a conversion of the one energy to the other form of energy, or transformation from one form of energy to the other form of energy. Potential energy get converted into the kinetic energy as the ball starts moving to the ground, as it comes to motion, students. Okay, now we can take another example or reverse of the same example. Okay, so at that time, student, what happened? Now, the ball, it reaches to the ground, it comes to the rest, at that time the energy will be 0. Now you have taken a ball and you throw it in an upward direction. Okay, so what will happen? The ball start moving to the upward direction, right? So as the ball start moving to the upward direction, you will say that since it is moving, the kinetic energy will be very more or very much. No, it is not like that. Because student, it is moving in the upward direction, and here what happened? The velocity is decreasing, and since the velocity is decreasing, the kinetic energy will also decrease, right? So velocity is decreasing, so kinetic energy will also get decreasing or will also get decreased. Okay, so on that basis we can say that since the kinetic energy is decreasing, potential energy will start increasing. Okay, so as it moves in the upward direction, we can say kinetic energy decreases and potential energy increases. So on that basis, students, we can say that one energy is decreasing, potential energy increases. After that, what happens when you throw it in the upward direction, after a certain time, you will see the ball will comes to a maximum, reaches to the maximum height. There it stops and finally starts coming down. So before it comes down, as it reaches to its maximum height, where it gets stopped for a few seconds, at that time the potential energy of the ball will be maximum, and there the kinetic energy of that ball will be 0. Okay, so as it reaches, suppose this is the maximum height covered by the ball, so here the potential energy will be maximum and kinetic energy will be minimum. What does that indicate, students? That the kinetic energy which was responsible for the movement of the ball going in the upward direction, kinetic energy starts decreasing, potential energy starts increasing. It means one energy is transformed, it's converted to the other form of energy. So this is basically, we are talking about the transformation of energy, student, in which one form of energy get converted into the other form of energy. Okay, now there are a lot of examples on which we can understand the transformation of energy, and the first one is the energy which is produced in the hydroelectric power plant. Energy produced in the hydroelectric power plant. Okay, so in the hydroelectric power plant, students, energy which is produced in the, so what is a hydroelectric power plant? Hydroelectric power plant is a power plant in which electricity is generated with the help of water. Okay, so with the help of stored water, by using the energy of the water, we will use that energy and help in production of the electricity, or help in generating the electricity. If you see, students, in that of a hydroelectric power power plant, student, I am saying that this power plant is used for generating the electricity, in which with the help of the water we generate the electricity. So basically what happened in the hydroelectric power plants, student, that we used to conserve, we used to store the water. You have heard about that of the dams. So what happened in the dams, or the dams basically prepared on the river also. So here we will store the water. Okay, storing of the water is the main purpose of that of the hydroelectric power plant, because from that only we will use the energy of the water, and which will help in generating the electricity. So basically what happens today, we will store the water in a water reservoir. Okay, and that water reservoir, if this is a water reservoir, students, okay, so we will use to fill this water reserve or that of the dams with the water, students, and from a certain height we will make the water to fall. Okay, so this is the height, student. We have filled the water up to here, and you will see that from a certain height we will allow the water to move through it. Okay, so as this water starts flowing from a certain height, then what will happen? The water, it is moving with a very high speed, with a very high velocity. So the kinetic energy will be very high. Okay, so this kinetic energy, what happened after that, students? That there is a turbine is present here. Turbine is a kind of a rotor. Okay, so which used to rotate. So when this high speed of the water falls on the turbine, the rotor or the turbine starts moving. Okay, so when this turbine it starts moving, student, this turbine is also connected to a shaft. Okay, so the shaft also starts moving, and the shaft is connected to the electric generator, and this generator help in generating the electrical energy. So shaft is connected to that of the electric generator. So you see here, student, water was made to flow from a height, so that its speed will get increases, and when this high speed water falls on the turbine starts rotating, and due to this rotation, the shaft which is attached to this turbine will also starts rotating, it will also starts moving, and finally the shaft which is attached with the electric generator makes the electric generator to generate electricity. So you see here, student, here the one energy is transforming into the other energy. So as you can see here, student, what are the different forms of energy, or what are the different energy which get converted from one form to other in that of the hydroelectric power plant, student. So at first what we had done, we had stored the water in the water reservoir. While storing the water up to a certain height will gives it energy, and that stored form of energy is the potential energy. Okay, so we will say, because you see the water is also moving from a certain height, we allow them to move, allow them to fall from that of the certain height. So the energy possessed by the water which is present at a particular height is the potential energy. So we will say that initially the water which is stored in the reservoir is consisting of an energy, and that energy is the potential energy. Okay, so potential energy is present in it. When you allow the water to fall from that of the certain height of the water reservoir, the water molecule starts moving with a very high speed, and as it comes to motion, as its velocity gets increased, as it starts moving, the energy which is present in that of the moving water will be the kinetic energy. So we will say that the potential energy which was present in the water, it get converted into another kind of energy, and that we call it as a kinetic energy. Right? Now this kinetic energy will make the turbine to rotate. Okay, so as the turbine rotated, the shaft which is attached with the turbine, the shaft is like that. So if it is attached with that of the turbine starts rotating, the shaft will also get rotated, and electric generator is attached with that of the shaft, and this generator, because of the movement of the shaft, because of the movement of the turbine, the generator help in producing the electricity. Okay, so due to the kinetic energy of the moving water molecules falls on the turbine, makes the turbine to rotate, and finally the electric generator starts working by producing the electricity. So you can say, students, that by the kinetic energy, this kinetic energy finally gets converted into that of the electric energy or electrical energy. Okay, so electric energy. So how this electric energy came, student? By the potential energy. So potential energy gets converted to kinetic energy. Kinetic energy gets converted to electrical energy or electric energy. Okay, so you have seen here the energy which is produced in the hydroelectric power plant get transformed from one form of energy to the other form of energy. Now, not only in case of a hydroelectric power plant, student, but energy is also produced in that of the thermal power plant. Okay, so here we were talking about the hydroelectric power plant, but if you see, the energy is also produced in the thermal power plant. Now, what is the thermal power plant, students? So, thermal power plant, student, what happened? Thermal power plant, thermal, it means thermal. Thermal, it means heat. Okay, so the energy which is produced due to the heat, basically in the thermal power plant, again like that of the hydroelectric power plant, we generate electricity, students. So here, with the help of the heat, we generate the electricity. So basically what happened in the thermal power plant, students? In thermal power plant, the main fuel that we use to generate electricity is coal. Okay, so coal is used in the thermal power plant. Now this coal is used as a fuel, students. Okay, so what we used to do with this coal, students, we used to burn the coal. Okay, and due to the energy which is present in the coal, it releases the heat from it. Okay, so fuel is what? Fuel is used to generate the heat energy. So basically in that of the thermal power plant, we use the coal as a fuel, and this coal is helpful in generating that of the electricity. How is this, student? Now we will understand this. Now this coal, first of all, this is a fuel and we will burn it. Okay, fuel which we will burn. As we will burn it, it will release the energy, or we can say it consisting of an energy in it, and that energy is the chemical energy. So this fuel is having an energy, and that is a chemical energy. So when you burn it, the chemical energy will get transformed into the other form of energy. So what happens, students? This coal is used to burn the water boilers. Okay, so basically we can say to boil the water, we use the coal as a fuel. Okay, so boiler consisting of a water. When we use this, when we burn this fuel, the chemical energy help in releasing the steam from that of the water boilers. Okay, so this coal burns to give the steam, to produce the steam. Okay, now steam is having a lot of energy. Okay, it is of a very high velocity. Okay, so when this this steam which is having a high velocity, it means having a high kinetic energy, when it falls on the turbine, it will make the turbine to move. Again here the kinetic energy only, so you can see that this chemical energy, this coal help in generating the steam, and that steam makes the turbine to rotate. Okay, so as the turbine rotates, students, we will say that chemical energy get converted into that of the kinetic energy, students. Okay. And that shaft starts rotating, starts moving. So kinetic energy will help in the movement of the shaft, and finally the shaft is attached to the generator which help in generating the electricity. So we will say that will also help in producing the electrical energy. So now we will try to understand that what are the different transformation of energy occur in that of the thermal power plant, student. So at first we burn the coal. As we burn the coal, the energy which is present in the coal was chemical energy. Okay, so we will say the chemical energy is present in the coal. So when you burn it, you are providing a heat to it and it starts burning. Okay, and then we will say that another kind of energy is produced in the water, and that is known as the heat energy. Okay, so when this coal consisting of a chemical energy in it, when you heat it, when you burn it, another kind of energy generated, and that is known as the heat energy. Okay, so when this heat energy is responsible for the formation of the steam, okay, and that steam will force on the turbine, the high speed or the energetic steam particles or molecules will fall on the turbine and make the turbine to rotate. So you see here, student, due to this heat energy which is present in that of the steam also will help in generating rotating the turbine. Okay, so in turbine, and the turbine is attached to the shaft will also start rotating. So we will say that this heat energy help it get converted into another kind of energy that we call as a kinetic energy. Now this kinetic energy is attached to that of the shaft, or the turbine is attached to that of the electric generator, and that movement of the shaft help in moving that of the electric generator, and thus the generator help in generating the electricity. So we will say that due to kinetic energy and another kind of an energy is generated, and that is known as the electrical energy. So you see here, students, that how the transformation of energy occurs in the thermal power plant, and that is the coal consisting of a chemical energy in it. When you heat it, this energy gets transformed into the other form of energy. That other form of energy is the heat energy. When this heat energy consisting of a high speed molecule of a water falls on the turbine, rotates the turbine, makes it move the turbine at the shaft which is attached with it. So we will say that this heat energy will get converted into another form of energy, that is kinetic energy, and then kinetic energy help in moving that of the shaft, and finally the electric generator which is attached with it help in generating the electricity. So we will say that due to this kinetic energy, electricity generated, so another kind of energy, that is electrical energy, is formed. So this is what transformation of energy from one form to that of the other form. So by this, students, we came to know that the energy, it can be transformed into the another, or energy can be converted from one form to that of the other form of energy. So transformation of energy is what? The conversion of the energy from one form to the other form, that is the transformation of energy. Now we will take some of the examples to understand about that of the energy converter, students. A lot of appliances that we use in our day-to-day life that is basically work on this principle of the energy converter. So let's say that an energy conversion from one form to other. Okay, so energy conversion from one form to other. Now I see here student, a lot of our appliances, right, we are talking about the first appliance that we use, the first device that we use in our day-to-day life is the electric motor. So I think most of the people, they are having the motor in their houses. What will happen when you switch on the motor? Then this motor will work with the help of the electricity it used to help the things. If we talk about the motor, so when you turn on the switch, then what will happen? This motor help in carrying the water deep inside from the ground. So here what is happening basically, students, that is when you turn on the switch, it means you are giving the energy to it, and that energy is the electrical energy. So electrical energy is there, okay, and due to this electrical energy which is present in it, it work on a particular object in lifting the object to a certain height. Okay, so we can say that the electric energy lifting, it means it is doing some work there, and that work is the mechanical work. Okay, so electrical energy get converted into that of the mechanical energy. So the energy conversion take place in that of the motor. Electric motor is the conversion of the electrical energy to that of the mechanical energy. Now if we see the second one, students, that we use in our life, that is electric iron. So what happened when you use an iron, at that time it was cold, when you turn on the switch, then what will happen? This iron get heated. Okay, so this is basically the materials which is present inside it. It will get heated. The coiling which is present in the iron, it get heated, and due to which the electric iron, it get heated. So we can say that the second one is the electric iron. So here you can see here, students, in the electric iron, the first one, the electrical energy is there. Electrical energy, because when you turn on the switch, you are supplying the electricity to it. So we can say that you are providing energy to it, and that is the electrical energy. This electrical energy helps in generating the heat, and due to which the iron get hot. Okay, so we will say that electrical energy gets converted into that of the heat energy. Okay, so here also what happened? There is a transformation of that of the electrical energy to that of the heat energy. We can take another example, and this is very common, student, and that is of a bulb. Okay, so electric bulb that we use in our day-to-day life, electric bulb. In case of the electric bulb, student, what happened? When you switch on the light, so you are supplying the electrical energy to it. So when you provide the electrical energy, what will happen? The filament which is present in the bulb, it will get heated. So we will say the electrical energy makes the filament heated, so that will provide the heat energy to the bulb. And due to this heat energy, as the filament get hot, makes the bulb to glow. Okay, so this electrical energy get converted into heat energy, and finally the bulb lights up. So we will say the light energy is produced after that. So one form of energy get transformed into other